Hello friends, greetings to all. I Prof.Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head network theory. So friends, as far as this session is concerned, so we will try to learn another exciting circuit analysis technique whose name is nothing but what? The Thevenin Theorem. So as you can see, with the help of this existing network, we will try to learn the basic strategy belongs to this Thevenin Theorem. Now as far as this theorem is concerned, so this theorem was invented by Mr. Charles Thevenin. He was the French engineer. So on behalf of his invention, the name given to that technique is nothing but what? The Thevenin Theorem. So first of all, we need to understand the objective behind this Thevenin Theorem strategy. So the objective is very simple. By using this Thevenin Theorem strategy, we can analyze any kind of complex either AC or DC circuit. Means that complicated AC or DC circuit is being converted into one Thevenin equivalent circuit. That is the objective behind this Thevenin theorem. Whenever we are interested to analyze the given network, whether it is AC or DC, our aim is to what? Determine the ohmic drop or the resultant current flowing through any particular branch. So with the help of this Thevenin theorem, ultimately we are supposed to design one Thevenin equivalent circuit. Means that given complicated circuit is converted into one Thevenin equivalent circuit. This is how this Thevenin equivalent circuit look like. There are two important parameters of this Thevenin equivalent circuit. These two important parameters are nothing but what? One is potential and another is nothing but what? Resistance. By analyzing that existing network, we need to determine the Thevenin voltage and the Thevenin resistance. Then and then only we can complete or we can convert that given existing complicated network into the Thevenin equivalent network. So what we need to understand? We need to understand these two steps, how to determine this V Thevenin and how to determine this R Thevenin. So there are certain design rules of this Thevenin theorem. So with the help of this existing network, we will come to know how to use the basic strategy of this Thevenin theorem. So as you can see, in this existing network, our aim is to what? We need to determine the current flowing through this 1 ohm of resistor by using the basic strategy of Thevenin theorem. So this is how this existing network will look like. In this existing network, there are multiple number of energy sources. As I told you earlier, there are two types of energy sources, either voltage source or current source. But in this existing network, there are two voltage sources. One is of 130 volt and another is nothing but 110 volt. And certain resistive arms we used to have with us, like 0.2 ohm resistor, 0.2 ohm resistor. Another third branch we used to have belongs to 0.2 ohm resistor. And our target resistor is this 1 ohm resistor. So we need to determine the current flowing through this 1 ohm of resistor by using this Thevenin theorem. Okay. So in that first step, what we need to do? In that first step, we need to replace that target resistance with two different terminals. Or we can say that once we are coming on to this conclusion, our area of interest is this 1 ohm of resistor. So virtually we need to remove that 1 ohm of resistor in order to determine or in order to tabulate this V Thevenin as well as R Thevenin. So in that first step, carefully you need to understand how that network will look like, right? By eliminating this 1 ohm of resistor. So this is how this network will look like. Remaining parameter are as it is this 130 volt of resistor. This first resistive arm of 0.2 ohm. Here we used to have another voltage source 110 volt. Here that 0.2 and 0.2, and our target resistor is lying in this branch. So that target resistor is no more with us. In that first step, that target resistor is replaced with these two open circuit terminals A and B. Means virtually that resistor is being eliminated. Instead of that resistor, these two open circuit terminals that can be abbreviated as A and B are connected in that circuit. Then as I told you earlier, our ultimate aim is to convert this existing network into the Thevenin equivalent circuit, which consists of these two parameters which are connected in series form, Thevenin and Thevenin. As far as these two open circuit terminals are concerned, so in between these two open circuit terminals, the desired value of load resistance is to be connected. In this existing network, the load resistance is of how many ohm? The load resistance is of 1 ohm. In this way. So this is how that Thevenin circuit is to be drawn, which consists of Thevenin, Thevenin, and the target resistance across which we are interested to determine the current. Now, by taking into account this design strategy, once that 1 ohm resistor is being replaced with these two open terminals, open circuit terminals A and B, then after that what we need to do, we need to determine the desired potential which is lying in between A and B or B and A. That voltage can be called it as a VAB or VBA. That is nothing but what? The Thevenin voltage. This is the most important step of this Thevenin circuit example that we need to understand. Once that target resistance is being replaced with these two open circuit terminals, then after that we need to determine the desired potential which is lying in between these two terminals, and that potential can be considered as a Thevenin or the Thevenin voltage. So in order to determine this VAB or VBA, what we need to do? We need to find out the shortest conducting path which is lying in between A and B, or which is lying in between B and A. Means, are you getting my point? What we need to do? We need to determine the shortest conducting path which is present in between A and B to determine the Thevenin or the Thevenin voltage. So for that purpose, we need to, from sake of observation, we are coming on to this conclusion that there are two conducting paths which is lying in between A and B. This will be the outermost path, right? And this will be the innermost path. So we need to determine the shortest conducting path. So accordingly, the conducting paths are nothing but what? Here I will draw the first conducting path or the outermost conducting path. When we start our journey with this A, we are heading through this 0.2 ohm of resistor, then another resistor is of 0.2 ohm, then this will be the voltage source of 130 volt, and we are coming across to this B. The moment at which we had started our journey from this 8th point, we need to conclude our journey at this B point. So for that purpose, we need to determine the shortest and the longest conducting path lying between A and B. So the outermost path is nothing but what? The longest conducting path. What are the elements lying within that outermost conducting path? There are two resistors and one battery. These two resistors of 0.2 ohm, and the voltage source of 130 ohm. At the same time, the innermost conducting path will be what? The shortest conducting path. Here I will draw the shortest conducting path. When we start our journey at this 8th point, we are heading through this 0.2 ohm of resistor. After that, one more resistor we are having. Here I will draw like this, whose value is, again it is 0.2. Then this will be the voltage source of 110 volt. And we are coming across to this B point. Okay. So as you can see, even though this will be the outermost conducting path which consists of two resistors and one battery, even though this is the innermost conducting path which consists of two resistors and one battery. So out of the two conducting path, we need to adopt any one conducting path to determine the Thevenin. Because according to the basic theory of this Thevenin circuit, we need to determine the Thevenin's voltage and the Thevenin's resistance. So how to get the Thevenin's voltage? Once the target resistor is being replaced with these two open circuit terminals A and B, the desired potential lying in between A and B is nothing but what? The Thevenin. So In order to determine this Thevenin, from sake of observation, we need to look around to this existing network key. There are how many conducting paths. Then after that it is being differentiated as the shortest conducting path and the longest conducting path. So which one will be convenient for we people? Obviously the shortest conducting path. Whether it is shortest or the longest, the Thevenin has to be same. Always it should exhibit the similar value that we need to understand. So if we consider the second conducting path or the innermost conducting path, which consists of these two resistors and one 110 volt of battery. So what we need to do? We need to determine the potential which is lying in between A and B. Means we need to determine the ohmic drop across this first 0.2 ohm of resistor. We need to determine the ohmic drop across the second 0.2 ohm of resistor. According to that Ohm's law, V equals to what? I into R. According to that Ohm's law, V equals to I into R. So we need to determine the current flowing through this 0.2 ohm of resistor, the current flowing through this second 0.2 ohm of resistor. Then and then only we can determine the potential which is lying in between A and B. Are you getting my point? We need to determine the current flowing through this 0.2 ohm of resistor and this 0.2 ohm of resistor. But another interesting fact about this existing network is nothing that okay friends, so coming back to the unique characteristics of this existing network, once this target resistor is being replaced with these two open circuit terminals, means virtually we don't have this 1 ohm of resistor into that circuitry. These two terminals are the open circuited terminals, which means what? Which means that there will be no current flow through this 0.2 ohm of resistor. Why? Because these two terminals can be treated as open circuit terminals. So we don't have the closed conducting path for this current flowing through this particular 0.2 ohm of resistor. So ultimately, as I told you earlier, we need to determine the potential which is lying in between B and A or A and B, that can be called it as a VBA or VAB. For sake of moment, consider it is as a VBA, right? When we start our journey at this point B, so we are heading through this battery of 110 volt. These are the polarity. Negative plate, smaller length plate means negative charge, and larger length plate is nothing but what? The positive charge. Then immediately after that we are having this fellow 0.2 ohm of resistor, but there will be a conduction of current through this 0.2 ohm of resistor, right? I was talking about these particular 0.2 ohm of resistor because the lower end of this 0.2 ohm of resistor is connected towards this open circuited terminal A. As this A and B are not connected physically, they are not connected to each other, means the current flowing through this particular 0.2 ohm of resistor is exactly equals to 0. If the current flowing through this 0.2 ohm of resistor is exactly equals to 0, means what? The ohmic drop is also 0, because ohmic drop equals what? I into R. The desired value of this resistor is nothing but what? 0.2 ohm, but the current flowing through this 0.2 ohm of resistor is 0 ampere, because these two terminals are treated as a open circuit terminals. So in this conducting path there are two resistors. Out of that two resistors, current flowing through this first resistor is equals to 0. So simply we need to determine the current flowing through this 0.2 ohm of resistor which is connected in that vertical arm. So how that circuit will look like? Here I will draw. This is how our circuit will look like. this is the battery of 130 volt. Here also we are having one more battery 110 volt, and this is 0.2, this is 0.2. So this is how that circuit will look like. The lateral part is being virtually removed because there will be no current flow through this 0.2 ohm of resistor, because these two terminals are the open circuit terminals. Then as far as this circuit is concerned, so purely it is a series circuit. Simply we need to determine the total current flowing through that circuitry by using the Kirchhoff voltage law, KVL, which says that the algebraic sum of all ohmic drops which are present within that loop are equated to 0. So when we apply this Kirchhoff voltage law, so at that time we need to assume the direction of current. As far as this loop is concerned, the direction of current is a clockwise direction. So accordingly, how this total current or fundamental current flow through this resistor which is connected in horizontal arm from left to right, positive to negative. Here from top to bottom, positive and negative. So friends, when we apply the Kirchhoff voltage law to this existing loop, the direction of current is assumed as a clockwise direction. So accordingly, this clockwise current flows in this horizontal arm resistor from left hand side to the right hand side, right? So accordingly, the polarities are, this is positive and this is negative. As far as this resistor is concerned, which is connected in that vertical arm, so this clockwise current flows from top to bottom. Then when we start our journey with this 130 volt of battery, so KVL equation will become, here I will write, as we are going from negative to positive plate, so plus 130 volt. As far as this 0.2 ohm of resistor is concerned, we are going from positive to negative. That's why the polarity of ohmic drop will be negative. So minus 0.2 times of this capital I current flows through that resistor. Similarly, as far as this vertical arm resistor is concerned, we are going from positive to negative plate. That's why the ohmic drop, that is nothing but what I into R across this resistor, or the polarity of this ohmic drop is also negative. So it will become minus 0.2 times of I. As far as this 110 volt battery is concerned, so as we are going from positive to negative plate, so opposite sign we need to consider. So minus 110 equals to 0. When we rearrange this equation, this minus 0.2 minus 0.2 minus 4 minus 0.4 times of I, this 130 minus 110, so obviously which will become plus 20, is being shifted to the right hand side of this assignment operator, so it will become minus 20. So I will become 20 upon 0.4 means 5 ampere. So this will be the desired value of total current flowing through this circuit. Means our aim is to determine the potential lying in between B and A. So when we start our journey from this B point, here first time we are encountering with this voltage source of 110 volt. We are going from B to A, means we are going from negative plate to the positive plate. So opposite polarity we need to consider, so it will become 110. And one more important thing is how this 5 ampere current flows through this vertical arm resistor top to bottom, right? We are going from B to A. B will be the lower end and A will be the upper end, right? So to that lower end, which polarity we are having? Negative. And to that upper end, which polarity we are having? Positive. So in this way, we need to mark this polarity to determine VBA or VAB. So as we are going from negative to positive plate, the ohmic drop B equals to I into R, or the polarity of this ohmic drop will be plus. So it will become 110 plus 0.2 into 5. That is nothing but what? the desired current flowing through that resistor. Means our Thevenin or VBA or VAB equals to 120 volt. This will be the first step. Here VTH equals to 120 volt. After that we need to determine the Thevenin. Okay friends, so in that second part we need to determine the Thevenin's equivalent resistance. So first of all we need to understand how to determine that Thevenin equivalent resistance. After tabulating this VTH, which exactly equals to 120 volt, one more time we need to look around to this circuit in which this target resistance is being replaced with these two open circuit terminals A and B, right? So while tabulating this Thevenin, we need to remember, irrespective of energy sources, whether it is a voltage source or current source, we need to relocate these energy sources. Means whenever we are having this voltage source, that can be treated as a short circuit element. So first voltage source and this second voltage source is no more with us, that can be treated as a short circuit element. If we are having the current source, that can be treated as an open circuit element. So while tabulating this Thevenin, we need to look around to that network from these two open circuit terminals, and from that opposite end we need to determine how many number of resistive arms we are having, how these two resistive arms are connected with each other, whether these are connected in series form or whether these are connected in shunt form. And while tabulating this resistance, if we are having the voltage source, that can be treated as a short circuit terminal. If we are having the current source, that can be treated as an open circuit element. That we need to understand. So once these two voltage sources are being replaced with the short circuit element, clearly as you can see, this is how that circuit will look like. Now virtually, while tabulating, we need to determine this Thevenin from these two terminals. Means virtually we need to think that these two terminals are virtually connected to each other. So as a result of this, we are having these two identical loops. Means these two resistors are connected in shunt form. So the parallel combination of this 0.2 ohm to the 0.2 ohm will become half of its 0.1. So how that circuit will look like? This will be the parallel combination of 0.2 and 0.1, and this will be the remaining resistance of 0.2, and here we used to have this A and B. So total resistance will become what here? 0.1 plus 0.2. So here Thevenin is exactly equals to how much? Thevenin equals to 0.3. Right? Thevenin equals to 0.3. So in this way, as far as this Thevenin equivalent circuit is concerned, so as I told you earlier, it consists of these two important parameters, Thevenin and Thevenin. So how this circuit is converted into Thevenin equivalent circuit? This will be the Thevenin of 120 volt. This will be the Thevenin of 0.3 ohm, and this is our target resistance of 1 ohm. So this is how that circuit is converted into Thevenin's equivalent circuit by the virtue of Thevenin and Thevenin. Finally, what we need to do? Finally, we need to determine, here I will write, we need to determine the current flowing through this 1 ohm of resistor. So basically this is the simple series circuit. We need to determine the current flowing through this resistor I. So I equals to V by R. So 120 upon this 0.3 plus 1 ohm, so 1.3 ohm. So approximately 92 or 93 something it is. The value which is coming out of from that division operation is exactly equals to 93 or 94 ampere, the desired current flowing through this 1 ohm of resistor. So this is how this by the virtue of this Thevenin's theorem, any complicated electrical network can be converted into the equivalent Thevenin circuit. So for that purpose we need to determine the two important parameters VThevenin and RThevenin. While tabulating this VThevenin, the target resistor is replaced with these two open circuit terminals A and B, and after that we need to determine the potential lying in between A and B and the total resistance which is to be looked around from that A and B. So I just hope you had understand all those things belongs to this Thevenin's theorem. Thank you.